welcome to another episode of Junction. My name is Simon Timms.
And I'm Eric Fleming.
And we are going to continue our adventures in durable functions today. We're going to take a look at another pattern. So I think we've done function chaining and we've done fan out already. So now we're going to move on to timeout. All of this code is up on the GitHub. And I keep saying I will link in the show notes below. I don't know if I actually ever do that, but I'll promise it again. And we'll see if I succeed. Anyway, timeout. So timeout is a really useful pattern here. And there's a few different approaches you can take to, or a few different applications of timeout, where people are putting a bunch of items in a shopping cart, and if they haven't saved their shopping cart after a certain period of time, or they haven't checked out the shopping cart for a certain period of time, you want to do something. Maybe you want to send them a message and offer them 10% off the contents of their shopping cart, or remind them that there's a shopping cart, or something to chase them anyway, and hopefully get them to come back and finish buying whatever it was they were buying. So I think of that as like a business case for applying a timeout, where business wants to start some process and then after a certain period of time perform some action. So it could be that you perform some action when an event hasn't happened, or it could be that you perform an event and then you wait a certain amount of time and you do that event anyway. So that's like the business case for it. There's also infrastructure cases around this. So something like I call out to a service and I wait 20 seconds to see if that service has responded. And if it hasn't responded, then I want to fall back and do something else, call out to a different service, make a change, some further task that I want to do, because I don't just want to wait on that service forever. I want to time box it with something. So let's take a look at how timeout works. So again, inside of here, we see that we basically have the same sort of task parallel library stuff that we had before. Same sort of application of it here. But what we're going to do is we're going to start off by creating a cancellation token source, and we're going to use that to cancel some stuff later on. So just keep that in mind for now. And then the first thing we're going to do here is we're going to set up a new timer. So timers exist on the context object that's passed in. So this is a durable orchestration context, and we're going to create a timer based on this. Now, the recommended way of doing this is to use context at current UTC date time. So it's tempting to use the same kind of date time libraries that you use for the rest of .NET, but because this stuff can be replayed at a later date, you're better off to use context at current UTC date time, because if you use the ever-changing date time that you get from datetime.now or datetime.utc now, that's going to be different each time you come into this function. So the context will look at this and go, oh, a new date time. I already have an execution of one date time, but I'm going to set up another execution for a different date time. So that's a good way of getting yourself into like an infinite loop inside of your functions. So what I'm going to do is I'm going to say I want this timer to activate 15 seconds from now. And this is the cancellation token that I have for it. So if my thing that I want to succeeds, then it's going to cancel the timer. Otherwise, we'll just let the timer run to completion. All right, and then I have another activity that I'm going to call asynchronously here. And this is just calling to a function called something time consuming, which is very exciting. It's just a sleep here for 30 seconds. All right, so now we've got our two tasks defined. What we want to do is then throw them into a task.whenAny. So whenAny takes a series of tasks complete. There is a kind of sister object or sister function call to this called whenAll, and that will wait for all of those to complete. So we're interested in just there we go. All right, so we kick that off and we wait for the result to come back in. And then we're interested in what sort of result is this. So if the result is the action that has passed, so this action right here, then what we can do is we can cancel the timer. I'm just going to log approved out, and then we'll continue going here. If it in fact fails, we're just going to log that the task has timed out. So in this case, the action that completed is going to be the timer. And then this is where we would do our compensating action. In this case, we're just printing out a message. Let's take a look at this thing running here. Okay, this thing is going to kick off here, and somewhere around here I have a window with the right URL in it. Just wait for this. Okay, so that's good to go. So I'm just going to go and refresh this here, and that's going to go and kick the transaction off. Okay, so if we watch the logs that come out here, we're starting the orchestration. You see it's kind of buried in there, but we're going to go and perform this lengthy task. So this kicked off at 9:25:08 UTC. So because it's 30 seconds, we'd expect it to complete about 38 seconds after, but we have another time that's 15 seconds in. So we're about 15 seconds in now, and you can see that we printed out that the task has timed out. So let's go and just make our task run a little bit slower, and we can check the flip side of this equation and watch what happens when our task actually does complete. Oh, my trial has expired. That's a shame. All right, so let's make our lengthy task only take 3 seconds this time. Again. That's a good plug for Ozcode, though. They do nice work. Okay. Off. All right. Just wait for the golden text if everything is working fine. There we go. We'll hit that up again here. Okay. So this time we should see that task completing successfully. So again, we're starting the orchestration. The timer is running in the background. Lengthy task is being performed. And looks like the lengthy task completed first, so we got approved.
Nice.
There we go. So if we waited out the full 30 seconds, we would not see that cancellation because that task has been canceled in the background. So we don't care about that. So this is, I think, a great pattern, super useful, just something to add to the toolbox.
So now,
Pick Seb up from school.
I should do that.
You should do that. Real quick before you go. So this kind of follows in the same suit with
Here's a reminder. Pick Seb up from school.
One take wonders. That's what we do. Just one take here.
Oh,
so
yeah.
you guys get the real world.
So this process, this whole way of doing this type of durable function follows the same suit, right? Like it doesn't have to be seconds. Like you could wait for minutes, hours, you know.
Right. So there is an upper limit at the moment, and that upper limit is 7 days. And the reason that it's 7 days is because these timers are implemented using the storage facilities that come with Azure, and right now that's limited to 7 days. I know that the end service bus people use a similar technique. I can't remember if they do that one in Azure or it's the AWS, but I was talking with them about how they implement timeouts that are longer than the underlying transport protocol can handle, and they have a hilarious hack that works pretty well. So I don't know if that's going to be something that the durable functions people take a look at too. But yeah, 7 days is currently the limit. Now, what you could do for that is you could set up a timer that executed in, say, 6 days, and then when it executed, you check your timestamps, and if it still needs to be something you push off further, then you just set another timer for, say, another 6 days out. And then in like 6-day increments, you can build up any time block that you want.
Right, and that's pretty nice because you're not paying for that whole 6 days.
Right. Yeah. So this just goes to sleep. It doesn't charge you anything for the time, but every time that you activate, I guess it's going to cost you a little bit more. So if your timeout is going to be 6,000 days, let's say, then you're going to get charged for 1,000 executions over the course of those 6,000 days.
Yep. Cool.
All right, great. Well, thanks everybody for joining us today, and we will record another one. You can see over here I have a few more that we haven't taken a look at yet. So retry, sub-orchestration, eternal and external functions. So we've got 4 more to record in this series, and then I think maybe we'll delve a little bit deeper into how you can get status on running durable functions and how you can cancel running durable functions. All right. Thanks for joining us. We'll see everybody next time.
Bye, everyone.